Welcome to the Deep Dive, the show where we take a stack of sources, all the research, the notes, the data, and pull out the knowledge you need to be, well, instantly well-informed.
Today we're putting golf's most frustrating paradox under the microscope.
Absolutely. The player who has, just exceptional ball striking ability, but then consistently posts these really disappointing scores.
Yeah, you see that person on the course all the time. Maybe it's you. They hit these absolute laser approaches. They're finding every fairway. Their iron control is beautiful.
But the score just doesn't follow.
Exactly. That incredible tee to green skill, it just fails to translate into lower numbers because when they get onto the short grass, the consistency just vanishes.
And the culprit, almost without fail, is the putter. It feels like this catastrophic breakdown of your stroke mechanics, doesn't it?
Mm-hmm.
The frustration just mounts when those 5-10 footers aren't dropping and then the 3-putts start creeping in, especially on the longer putts.
Right. And you assume the fault has to be in your hands or maybe your rhythm. But our sources today, which come from a deep analysis using the scientific Puttalyze methodology, they suggest the root causes are actually much deeper.
Deeper than the stroke itself.
Much deeper. They reside in your brain and in the actual physics of the green.
Okay, so this Puttalyze analysis, what's the beauty of it?
Well, it takes the very subjective feel of putting and it just replaces it with data-driven precision. It transforms performance from, guesswork to calculation.
So it's identifying the real, often hidden root causes of that inconsistency.
Precisely. It's a system that's designed to give a skilled player the technical clarity they need to finally turn those greens in regulation into birdies.
All right, let's unpack this then. We're going to look at some truly eye-opening findings that emerged when a skilled player's putting was analyzed. And our mission here is to show you exactly what factors are, frankly, under-discussed in putting and how you can apply this precision to your own decision-making on the green. So we have to start where the analysis did with what they call the invisible obstacle.
Mm-hmm.
Before the club even moves, your brain has to process all this information.
Mm-hmm.
And one of the first most overlooked factors they found was a flaw in visual perception. I love the phrase from the source. Seeing isn't always believing.
It's so true. You could have a technically perfect stroke, but if the input your brain is getting, the actual distance to the hole, if that's wrong,
then the output, the stroke itself, is going to be wrong too.
It has to be. And this deep dive, it pinpointed a very specific subtle vision condition in the player they analyzed.
Which one?
It's called latent esophoria.
Okay, that sounds pretty technical.
It does, but here's what it means in simple terms. It's a condition where your eyes tend to overconverge just slightly. So for a golfer, this means you misjudge distances by subtly pulling targets, like the cup, a little closer than they actually are.
So your brain sees the hole, but it calculates the distance as being shorter than it is in reality.
Exactly.
That is genuinely surprising. Most of us just assume our eyes are working fine. So if your brain thinks the hole is closer, what happens to your putt, especially, say, on an uphill slope?
You consistently leave it short. The analysis showed this bias was most severe on uphill putts. The player would make a stroke that was designed to send the ball, let's say, 12 feet, but the actual distance required was more like 15 feet.
And that's not a mechanical flaw.
Not at all. It was an unconscious visual bias that was just completely altering the required stroke rhythm. It's kind of like having a camera lens that's just a little bit miscalibrated.
And they were sure about this, right? The sources detail the specific tests they used.
Oh, they went deep. This was serious visual motor testing. They used the Brock string to check convergence. They did fusion and suppression testing, distance estimation trials with eyes closed. They even analyzed head and eye movement symmetry during the setup.
So they weren't guessing. This was a physical neurological diagnosis.
Absolutely.
Okay, so if you have this, what's the immediate fix? The science-based coaching cue. Because you can't just fix your eye muscles on the spot.
Right, and the adjustment is just a brilliant piece of practical sports neurology. If you know you have this tendency, or even if you just habitually leave uphill putts short, you have to consciously, mentally project the cup 30 to 50 centimeters farther away.
So you're not changing your stroke mechanics, you're changing the visual target that your stroke is trying to reach.
Exactly. That small mental shift forces your brain to compensate for that latent convergence. It activates a greater sense of the energy required, and you deliver a more appropriate stroke rhythm that sends the ball past the actual hole,
giving it the speed it needs to reach the true distance.
That's it. The problem wasn't a flaw in the swing. It was the flawed input the brain was giving to Baywing. The key takeaway for you here is, sometimes before you blame your technique, Maybe check if your brain's interpretation of distance is the first mistake.
Wow, that is a huge shift in perspective.
Yeah.
Okay, let's move from that invisible obstacle to the visible challenge of just reading the green. This is where we get into the core of, sophisticated green reading.
And the very first step, the absolute bedrock of the Puttalyze system, is identifying the fall line.
Okay, so before we get too technical, why is that the essential starting point? I mean, isn't just looking at the cup and judging the slope around it enough for most people?
It really isn't, because just looking from your ball gives you a subjective viewpoint. The fall line is the objective, pure gravity line.
The steepest path down from the hole.
That's it. You should literally visualize it as the path water would take if you poured it right next to the hole. It represents the pure uphill-downhill access relative to the cup, and it doesn't matter where you're standing.
So it anchors your entire read in objective reality.
Precisely. And the source material really stresses this. Identifying this line is monumentally important because once you find the fall line, you've already uncovered about 80% of the information you need.
80%.
Yeah.
That's a huge claim. How does knowing that one line unlock so much of the problem?
Because it establishes two immutable rules for any putt. First, every single putt that's to the right of the fall line will break left.
Okay.
And second, every putt that's to the left of the fall line will break right.
And if your ball is sitting right on the line,
Then you have one of the very few truly straight uphill or downhill putts on the green.
knowing those two rules just instantly removes all the guesswork about direction. It brings so much clarity. Okay, so practically speaking, how do you find this line without any special equipment?
There are 3 steps. First, walk around the hole slowly and just feel the strongest pull or gradient with your feet. Your body often senses the steepest slope better than your eyes.
Okay, feel it first.
Second, consciously imagine where rainwater would flow past that cup. And then finally, the most reliable visual step. Crouch low behind the hole, not behind your ball.
Right.
From there, you can visually confirm that steepest direction. That simple process finding where the green falls fastest is the key to escaping pure guesswork.
Right, so once we have that objective fall line, we can move to the next layer of precision, which is establishing the endpoint.
Yeah.
How does the methodology get us from knowing the direction of break to knowing exactly where the ball needs to start?
Right. This is where we move from just sensing the slope to actually calculating the geometry of the putt. We use that fall line as our gravitational reference point.
Okay, so walk us through the visualization here because this can be tricky. Let's imagine a 15-foot putt that's breaking left, which means our ball is on the right side of that fall line.
Perfect example. The first thing you do is walk to a position that's roughly 90 degrees to the fall line, which is usually where the break is most pronounced.
Okay.
From that spot, you do a little thought experiment. You ask yourself, if I aimed the ball directly at the hole and it missed on the low side, how far would that ball roll past the cup before gravity pulled it to a stop?
I see. So that spot where the ball would finally rest on the low side, that's what the source is called the drop point.
That's it. Now for the final step, which is really intuitive, you mirror that exact distance from the drop point over to the high side of your actual putting line. That mirrored spot on the high side of the cup, that is your calculated aim point.
That's brilliant. It makes the break visually predictable, makes it consistent. But here's where it gets really interesting, because there's another point to consider, the distance point.
Yes.
We have the aim point where to start it, but we also need to know the distance point, which is where the ball would ideally stop if it rolls out past the hole.
And this distance point is often what separates a good putt from a missed putt that felt like it was on the right line. It explains why you can hit your aim point perfectly, but still miss short or long.
So the relationship between aim point and distance point is dynamic.
It's totally dynamic. It depends entirely on the slope and the speed you need.
So how do they relate to each other?
It's all about gravity's influence. If you're putting from below the hole, so an uphill putt, your ball has to fight gravity.
Right.
Therefore, your distance point needs to be farther than your aim point, often by a lot, because the ball just needs more speed and momentum to get up that hill.
And so the opposite must be true for downhill.
Precisely. If you're putting from above the hole, downhill, gravity is helping you out. You need much less energy, which means your distance point should actually be shorter than the aim point to stop the ball from racing past.
You want it to die at the hole.
Exactly. And if you're putting from the side, perfectly level, about 90 degrees to the fall line.
Then gravity isn't really helping or hurting the momentum.
Right. So the aim point and the distance point are nearly aligned. And what's so critical here is that this whole process is a shift away from pure feel to data-driven decision-making. That's the power of the Puttalyze system.
And when you say data, how precise do these calculations get? The sources mention tables. What kind of variables are we talking about here?
We're talking engineering level calculation. The exact values for endpoint and distance point aren't just left to chance. They're derived from tables that factor in 5 major variables. The specific stimp meter speed of the green that day,
Okay.
the precise green slope percentage, not just steep, but is it 2% or 4%? The putt's length, the angle of your ball relative to that fall line, and even the desired rollout past the hole. You are replacing subjective judgment with objective measurement.
That leads us perfectly into the final and I think often forgotten element of reading a green. Speed.
Yeah.
It is so easy to think the break is just a fixed quantity, but the sources show that the amount of putt breaks changes fundamentally based on its speed.
This is the concept of time on break, and it's a beautifully simple principle of physics, really. The longer a ball spends rolling across a slope.
The longer it's exposed to the pull of gravity.
Exactly, and therefore the more it breaks.
So let's apply that. Let's apply time on break to our two main scenarios, uphill and downhill, just to make sure everyone really gets this.
Okay, so when you hit an uphill putt, the ball needs a lot of energy to get up that slope, right? So it travels faster across the surface.
Right, it's moving quicker.
Because it's moving quickly, it spends less time being exposed to the slope's gravitational effect. The result, it breaks less. You can take a much more aggressive line.
Which kind of goes against the common idea that uphill putts break the same as flat ones. The speed actually mitigates the break.
Precisely. Now, conversely, on downhill putts, the ball is decelerating rapidly, or you hit it softly on purpose. It's slower, so it stays on the slope for longer.
And that prolonged exposure means gravity has more time to act on it.
Maximum time. Therefore, the ball breaks significantly more. The rule of thumb is simple and it's foundational. Soft putts break more than firm ones every time.
This means green reading is a dynamic skill, not just a static observation. It forces you to ask two critical questions before every single stroke. How fast do I want this ball to roll? And does the line I've picked actually match my chosen speed?
Because if the line and speed don't match up, if you, say, pick an aggressive speed but you chose a gentle break line, the ball will miss. The whole Puttalyze concept is designed to harmonize these two variables. You read the fall line for direction, you calculate the endpoint for the start line, but your decision on speed, your time on break, is what dictates the final result.
And this integration of science brings us to the summary of the whole system, what do you call the Puttalyze triangle. This is where it all comes together.
Right. The system says there are 3 fundamental integrated elements that have to work in harmony for a successful putt. First, you read the slope using the fall line.
Okay.
Second, you set the line using that aim point visualization. And third, you apply the correct speed using the distance point and that time on break concept.
You only get consistency when all 3 points of that triangle are addressed.
They have to be integrated.
Okay, let's give the listener a quick, comprehensive action plan that ties this all together. A checklist for calculated performance on the green.
Sounds good. Start with the internal factors. Address your visual perception. If you are a notorious short misser on uphill putts, try mentally projecting the hole 30 to 50 centimeters farther away.
Next, conquer the green itself. Master fall line reading. Always find the steepest slope direction first to anchor your read in objective physics.
Then, calculate the path. Use aim point estimation. Visualize that mirrored drop point from the 90-degree angle, and then immediately follow that with distance point calibration, adjusting your target past the hole. Farther for uphill, shorter for downhill.
And finally, match your intention with execution. Speed matching. Consciously factor in time on break when you pick your tempo, knowing that soft putts break a lot more than firm ones.
The whole system is designed to move that skilled ball striker beyond just guessing and into dynamic, calculated performance where, finally their short game can match their long game.
It seems like what this deep dive really shows is that to maximize your putting, you have to connect 3 totally distinct fields. The subtle perception flaws in your own vision, the biomechanics of your stroke, and the precise physics of slope and speed.
That's the synthesis.
And this raises a really important question for you to think about. If the speed of the ball, that time on break, is what dictates how much gravity influences its path, how much should your conscious calculation of speed override your instinctive reading of the break when you're faced with a really long sweeping downhill putt? When you feel one line, but the math tells you to aim higher because you must hit it softly, where does science take precedence over instinct?
Something to mull over the next time you step onto the practice green.
Thank you for joining us for this deep dive. We'll see you next time.